Hello. Today we'll be talking about different types of magnetic sensors. There are a variety of magnetic sensors out there, but there are really four main ones that I want to talk about today. The first one that we should talk about is the magnetoresistive sensor. What this is it's a sensor that will measure the strength of a magnetic field within a change of resistance. So if you're running a voltage through that and the resistance goes up, you're going to see your voltage drop. You'll see a change, a measurable change by the strength of the magnetic field. For example, I have a magnet here, and if I had a sensor here, as I got closer to the sensor, the resistance would change. And as I got farther away, it would change. Or if I used a bigger magnet or a smaller magnet, or as I came by and the magnetoresistive sensor, you would see that resistance change that is measurable through voltage. The next sensor is the Hall effect sensor. And it's a lot like the magnetoresistive, except it's kind of the inverse. You see a change in voltage instead of a change in resistance. So as the magnet gets closer or farther away, you'll see your voltage change higher or lower. Very similar principles, but a different mechanism for getting there. You might know these sensors they're in motors, they're in a lot of things that are moving. One simple example might be when you have a sensor on a door and on the door frame, and as you open the door, it'll be able to tell you that the door is open because it's not close to the sensor. And as you close the door, that magnet will come in proximity to the Hall effect sensor or the magnetoresistive sensor, and it'll be able to tell you that the door is now closed. That's a very simple application. You can use these sensors for a lot of things, even positioning, to determine how close or far a magnet is along a given distance from the sensor. The next type of sensor in there would be a reed switch. Now, a reed switch is a mechanical sensor. So while the magnetoresistive and Hall effect sensors are more electronic, they don't have moving parts per se. The reed switch actually has a moving part. As you get close to a reed switch, there's a piece that will actually move and make a connection between a left and a right side and make an electrical loop. So it's more of an on-off type of thing. Either it's connected or it's not. You can't determine how close the magnet is or how far away. It's a very simple mechanism. In fact, in our example of determining if the door is closed or open, a reed switch could work well for that. It could tell you, is the door closed? The small piece will be connected. If you open the door, the small piece will be disconnected. That's a simple example, but it can't tell you how close the door is to being closed, whereas a Hall effect or magnetoresistive sensor could. In some cases, people have used reed switches to determine position by lining up several of them, let's say at every 1/4 inch, and then with 1/4 inch accuracy, you can determine your position along the line using reed switches. They're probably the most basic of all magnetic type sensors. The last one I want to talk about is the magnetopot. The magnetopot's probably a little less well known. It actually stands for magnetopotentiometer. So it's a potentiometer or a variable resistor that is actuated with a magnet. So here I've got an actual magnetopot. And how it works is I can take my magnet and connect to an internal magnet in the potentiometer. And you can see here, this is a resistance reading. It's at about 140 ohms. And as I move it along this line, you can see the ohms is changing and going higher and higher. Now we're at 3.3. Now we're at 5. So we get farther on down, getting up closer to 6, 7, 8, and so forth. So that resistance is going to change as you move along the line. This becomes similar to how someone might line up a bunch of reed switches to get measurements along the line at every 1/4 inch. This is similar, except it's continuous. There is no discrete measurement. You have a continuous, even measurement anywhere along this line. Now, why would you use this type of potentiometer? It's actually really advantageous when you need to measure a position of something through a wall. So here I've got a piece of acrylic. You can see it's not super thick, but there's some acrylic there. I'm going to place this on top of the potentiometer, and so now even though we are we've got a wall between us, I can now still use this to determine position along that continuous line. You can get high accuracy without having contact. Now, similar to, or unlike the magnetoresistive and Hall effect sensors, the magnetopot cannot determine how close or far you are from the sensor. It is truly similar to the Hall effect. It's either on or it's off. When it's on, then you can measure along a line or an arc. These are also made in arcs or other types of, really you can customize the shape of a magnetopot to whatever you need. But does not give you strength of magnetic force. So it's a different type of measuring mechanism to a magnetoresistive or a Hall effect sensor. And so those are your 4 main types of magnetic sensors. And I hope that's helped you understand what you need to do next in your project. Thank you.